New live. We are now live. This is the 6th episode of building a real industrial AI inspection system from scratch, where we have already here the setup. You see I have a conveyor belt on my side where we're going to simulate a scenario, an industrial scenario where we have products passing on a conveyor belt. What we are doing here, we're doing now an open source inspection system that you can find at pysource.com InspektLine. So I'm going to paste this down in the chat. So chat, if you want to check this, I'm going to pin this in the chat. And before we move further, chat, let me know if you hear me clearly, and if so, please write where are you watching from. I would be very curious to see where everyone is watching from in this moment if you're just joining this live. And what are we going to do now? I have two specific goals for this live. First, we are going to have a model. So you see here we have steel rings. That's the we took a data set for this in the previous live, so I'm going to show you it right here. We took a data set, so we took hundreds of images of these steel rings. In these last days, I trained the model, so I will quickly go you to this. Hi, welcome from Germany, VL5R667. Welcome from Germany. Nice to have you here. So this is the object that I'm using in this moment, steel rings. So I took a data set in the previous live. I will quickly show you how I trained the model that can detect these steel rings. We will see the detection of this in real time. And what are the two main goals? The first is that we want to count the objects. So we will do live counting of this object of the steel rings on the conveyor belt. And second, that you can select ROIs or region of interest, and we can make the counting for single region. Why I decided to select the ROI? Because these are something the most common requests from companies when you have such system, because maybe you want only to select an area, maybe you have multiple lanes, so you want to count for each specific lanes. Of course, here I have now a very basic setup, but we will simulate like if we have more lanes so that we can count separately per each lane. So take everything that I'm showing right now here as a test, as a, let's say, prototype that can be expanded to bigger cases, bigger conveyor belts, more complex scenarios, and so on. Chat, feel free to ask any questions along the way. I'm here to just to chat with you, not only to, so this is not a lesson, this is a live interaction where I'm building. Feel free to ask questions about the project, or if you want to interact about in general about computer vision, I will try to reply. And now let me tell you something more about this project. So you will find it pysource.com. I mean, it's GitHub, pysource.com InspektLine. The link is in the chat. Feel free to put a star on it so that you will be following this project. You will be notified when there are changes to updates to this project. This will be fully free open source, this version right here, and then I'm planning to make also a more advanced version for companies that will be a paid version where I will add more features, for example, optimizations for specific devices, where there could be NVIDIA Jetson, improvement of performance, integration with database, many other things. So I will see auto split, and along the way we will discuss also about this. And now let's get right into the core of our topic. So in the previous live, we collected data set. Where do I have the data set? I will show you right now where I have the data set. So let me run the software. So I put the data set into a labeling software. This is a software that I built that I will release soon, and you will be, if you want to use this software, stay also updated too, because I will be releasing soon the software, soon, I imagine around 2-3 months. Of course, I have to finalize some stuff, but I have the most of it. So I have 493 images. You see, we go image 10 of 493 like this. So these are the images that I collected in the previous live. What do we need to do? We need to train a model to using these images so that this model can detect the steel rings. What I did in the previous days, I did the annotation. Annotation consists in drawing polygon for each single object like this. So what is this? This is steel ring. No, I didn't make the drawing exactly perfect, but that's the idea. So for each image, so for each polygon, like this, drawing for all 493 images. So I will show you now. I have the updated, I have the data sets. So let me just share this so that I will show you what I have. I just need to find it from my other hard drive, so give me a minute while I find the data set. So the data set, I have it on download, I believe. Download steel rings. Okay, let me now import the labels. So I'm moving now the labels from my machine. Okay, class 0 steel ring, it's the same. Confirm mapping. So you see now I imported the labels that I had already. Hi Faza from Ireland, welcome to the live. How are you, Faza? I remember that you were moving, you were pretty busy with the moving. So I hope that you manage everything and now you have more time for yourself. So here you see I have the labeling. So I have a polygon for each of them, like this, for all the images. So what do we have to do in this case? We need to train a model, and so train, I will show you what's the idea. So train, we need a segmentation model. We have, let's say, 4 types of training. We have the object detection, where you train to only detect a bounding box, so you will see a rectangle showing you the position of the object. Segmentation, instant segmentation, if we want it more precise. So instead of having a bounding box, a rectangle, we will have a polygon, so the exact boundary of our object. That's exactly what we have here. So if we wanted bounding box, we will have something like this. Just something like this, for example. But in this case, I want a polygon. Polygon is more precise. We will remove all the background that we don't need. So train. And then we have other two types. We have the classification. So what is it? So you cannot detect, but you say what's that image, or all the objects that are in the image, but without specifying the location. And then the points, if you want just to detect specific points. I'm great, I was very busy. I'm now back in the development of the vision system. Oh, that sounds awesome. How is it going with the development? I remember that you mentioned something about the architecture, that I don't know if it was about the system, but that it broke at some point, the architecture, then that you had hard time to using the vibe coding to fix that architecture. And I remember you were suggesting me to improve already step by step the refactoring of the architecture, which was a great suggestion. And I'm doing that quite often with my other side projects. I'm trying to keep as minimal as possible because I notice how complex things get very soon, especially if you add a lot of features. So I'm also very careful not to add too many features. We're back here. So instance segmentation, model. Model, I choose RF large model. This is a new model from RoboFlow that I tested, and it's quite impressive, quite good. Previously I was using the YOLO models, but now I'm very happy with the RF model. There are many advantages with this, and I can share this in another dedicated video if you are interested about this specific model. So what I did, I created this model and then start training. And of course, this is an operation that takes hours. You need to have a specific graphic card to properly handle this. So I have the RTX 4090 in this moment, NVIDIA RTX 4090, which has 24 GB of video RAM. And you can do this also with other smaller cards that should have at least 12 GB of video RAM. I noticed that's below that you will definitely not manage to do the training. You see now already the NVIDIA it's being used, it's filling the memory, and then this operation takes hours. So that's why I did this already before the live. But now I'm just showing you that we're doing the training of the model locally, and that's possible now or just on my machine. So I will stop the training because I have this already. I'm going to quit from this software, and now let me take the model that I have. So I have the model. I have just to find where I put, because I'm using two accounts on this machine. I was planning to bring the model already here before the live, but I completely forgot. So I will look for it in this exact moment. So fast, as you say, I moved to Pysource and the app. So before to look in the moment, I will read some chat. Moving to Pysource and the app is now getting there. Okay, that's awesome. I'm actually stuck because I don't have the graphic card, so I'm basically focusing on the machine vision part. Okay. Well, you could always, I mean, you for sure know this, rent some cards for, okay, but that would be cloud. Yeah, like never mind, yes. You could focus on making as optimal as possible. I would say graphic card, it's necessary to some extent. But for testing it, for prototyping it, even with the CPU, you will not get the real-time speed usage, but you can get maybe a couple of frames a second using just the CPU, and that could be sometimes good enough. So Python projects. Let me find this model. Okay, I think I found it. Engine, real-time size. Okay, I finally found the model. So let me move the model to this project. Actually, let me move it. Yes. I will now put a folder, models. Okay, already exists, so I don't have to put it. Models, let me just copy paste my model into this directory. Like this, checkpoint. Okay, models. Okay, I have my object segmentation model, which is a PyTorch file with the size of 140 megabytes. And that's the one that is going to detect the steel rings from this conveyor belt right here. So let's do that. Let's do that right now. So checkpoint best total PTH. Let's now run. So I can close the labeling software. Let's now run the main right here. So this is now our InspektLine software as of today. That's what we get. So we have a view from the camera. So this is real time. So as you see now on my hand, what do we do? Now we need to load the model, which probably will not do anything anyway because I haven't integrated the segmentation, but let's see. We have load model. Where is the model folder? Well, I've been mixing the projects somehow. I think that I put the model into the other project. So that's what happens when we open two files, two PyCharm projects at the same time, to have a bit of confusion. So here we don't have any model folder. So models right here. Can you tell from where did you manage to get the physical setup and how much it costs? Okay, physical setup, this one, I found it from a company called Vevor. Vevor, this is the name. I don't know now if, I don't remember if it was from their website, but it was a very quite good cost setup. I probably €300 for the conveyor belt. So conveyor belt, I think it was here that I found it. Vevor.com. Conveyor belt, not conveyor bell. Okay, I found. Okay, this is the exact one that I have. Let me now, for now, hide a bit the setup. Okay, like this. So this exact one that I have, it's a very nice product for prototyping. Like it's big enough to play around with it and small enough to fit it in an office space. So this is one product, the one that I'm using. And you can change the speed of a conveyor belt, you can change the direction. It's pretty cool, so I'm happy with this product also for the price that they offer. And then the camera is, I have this camera die hang imaging. This specific camera, one of these. So camera plus lens, I will say around. Okay, you need camera, lens, and frame grabber from the camera. Oh yes, true. That's very economical. Like usually you find conveyor belts starting from €900, €1,000, but very by chance, very randomly, I somehow found this one, and I just got it right away. It's great. So great for tests. So if anyone want to do some tests, that's something that they could get. And camera setup, you will be around, so the camera will cost more than the conveyor, even the basic cameras. So camera plus lens, so let's say €250 camera, lens around €100, the lens, so 350. You need a frame grabber. So the frame grabber will be the one, let me show again the double setup here. So industrial camera, this is Ethernet connection. This is PoE, power over Ethernet. So the frame grabber will provide also the electricity through the Ethernet to run the camera, which is cost between €50 and €100. I can't remember now. That's also what is So before, let me finish. So here, 250, let's say 400 camera setup and 300 this, so €700 total cost for this setup. Also, what is the use case of a frame grabber? Can we connect the camera directly to the PC? yes, you can. Here, I use this for two reasons. Mostly for simplicity. So because the frame grabber already provides the power, so it's a specific frame grabber which provides power over Ethernet. PC don't do that. So in that case, if you don't want power over Ethernet, you need also to connect the camera to electricity in another way. So for simplicity, I just prefer to use this way. There is a second reason why you might want a frame grabber, and it's if you have multiple cameras. You can connect multiple cameras because the frame grabber looks like a router where you can connect 4 cameras at the same time. But what's the specific of this? That with the frame grabber, you can grab the frame at the same time. And if you have multiple cameras in the same setup, you want to make sure that you grab the frames at the same time, not to have some delay on one camera or delay on the other camera. So these are the main advantages of the frame grabber. Not necessarily highly recommended to have it. So I move the model now to this InspektLine, select folder. Well, now chat, we're going to start and entering with the integration of the model. So here I'm loading the model, which is not giving anything. What we're going to do right now we are going to, you're welcome, Faza. Now we're going to do one thing. We're going to implement the loading of the model into the software, and then after this we're going to identify in real time the objects. So let's do that right now. So like this, so that we can focus now only on the coding for this specific part. And now we go with vibe coding. I'm using Claude Opus 4.6 just for reference if anyone is doing vibe coding right here. Are you chat doing vibe coding? What's your favorite model? Also, I've been into vibe coding lately and there is a lot I could share. Maybe I will make a dedicated video on YouTube on good side and bad side, because it will be nice to say vibe coding is amazing, but there are so many other implications that I've been through lately with vibe coding while working on different projects than this one. So I would be happy to share some stuff about it. Claude Opus 4.6 is my favorite so far, so I'm going with that. What do we want to do? I want to integrate object detection and instance segmentation. So object detection, detect bounding boxes model, instance segmentation to detect the exact boundaries. I have now instance segmentation model, so I want to integrate both of these using RF that from RoboFlow. As simple as that. Plan. I've moved to the same model also. Okay, yeah, I think I will debate if it's one of the best or not. What I was doing in the past, I was using Claude Sonnet quite a lot and Claude Opus for more complex tasks. Now I decided I will use Claude Opus just for everything, because it's better to have a better model than try to debug later. Claude Opus costs, at least in this GitHub Copilot subscription, 3 times more. So if you see here the models, there is 3x. So instead of using 1 token, you use 3 times the tokens for each call. Which I estimated, so I'm making the calculation, if you pay for it from GitHub Copilot, is 12 cents of dollar for each call. For the first 1,500 for each call of Opus, because it's 4 cents per 3. which you have some discount in the first 1,500, but then yeah, it's 12 cents, which is, let's say, very worth it for what you get. Now, I'm using the plan, so of course we have different ways. We have agent, plan, ask. I'm using plan mode because the plan before taking action will show you and you can discuss and change something. So I prefer now to use the plan to talk a bit more with what are my goals and see if the copilot's goals are aligning before going there. Integrate RF object detection instance segmentation. So far it's good. The current system only supports image classification. That's true. So we want to integrate, because the current system of InspektLine that I made in the previous lives was very basic, only only classification. So what are the steps? It's going to do detector RF detector.py. Okay, what is going to this to? So it will expose the frame that we grab from the camera, returning a list of detections, bounding boxes, class label, confidence scores, and optimal segmentation masks. Pretty good. Extend detection settings in settings service. Add model type. You can field classify RF to detection setting. Update the inspection service. Modify load model to branch setting detection model. Okay, the inspection service should be this on the side. I'm not sure about what is talking about here. Update inspection service. On settings, detection model type. Add overlay rendering to video label. Okay, so the overlay, this means that each time it detects hours. It detects hour rings. It's going to put an overlay so that we're sure that we are detecting them. It's a simple basic drawing on the overlay. So so far everything is good. Even some of them I'm not sure, because there might be some part of the software that I try to remove but are still there. So for now we go with it, and I can improve it later on the way. Add overlay render. Okay, wire detection results into the frame loop in main window on new frame. Okay, so far it's good. In the main window we have the loop where we display the frame in real time. So this one is our main loop where we see this in real time. And so the detection needs to be shown in this main loop. So far, like this is telling us it's all okay. Update requirements RF data and supervision packages and dependencies. So the requirements is where we have our file, our libraries, Python library that we need to have installed. And this is recommended to install two more, RFDet, which is the object detection and object segmentation model, which we need. Supervision, it's another library from RoboFlow, which does very, let's say, image processing utility operations, for example, drawing and all such stuff. I haven't used supervision personally, but I saw some of the members using it. That's what I see it does. It's not strictly necessary. So now, for now we keep it, but at some point I probably will remove it to just keep something more basic and just keep OpenCV. Further consideration, pre-train. Okay, why I want to remove it? Because I want to keep the software as minimal, as basic as possible. The more things we add, it means the more processing this will require. And since I want this to work on different devices that could be NVIDIA Jetsons, could be small devices, also Raspberry Pi, maybe using some AI kit, but I want to keep this as minimal as possible. For this reason, I want to keep the code as clean, as basic, as simple as possible. So further consideration, we have pre-trained, fine-tuned model, should load model on the home page, support loading local fine-tune RFDet checkpoint, PTH alongside using the default Coco pre-trained model. Recommended support both file picker for PTH checkpoints. So this, yes, we want to load to load the fine-tuned models. That's what I have. So the file pth, it's a fine-tuned model. This one, which I put, okay, this, where is it? Where is it? I think again I put it in the wrong folder. InspektLine models. Let's put it here. So this one is the fine-tuned model that I trained. That's what we want. Performance, RF depth inference can be heavy. That's true. Inspect frame background thread with a config. Okay. Inspect frame in a background thread with a configurable interval the existing detection frequency setting rather than blocking the frame loop. Option A, dedicated Q thread. Option B, a sync with frame skipping. I will say, okay, this is a good point. We want to have separate thread from the graphic user interface and the backend operation. So everything that's the detection of the objects needs to be done separate from the user interface. So if there is some slowing down into the detection because we don't have enough power for any reason, so if you have a low power graphic card and you can get a few frames per second, you can get a few frames per second, that's fine, but you don't want to even let the user interface waiting while there is the detection. So we need a thread from the user interface and a specific thread for the backend of the software. So in this case, yes, let's use multi-threading. Let's use multi-threading approach. And then supervision dependency. The RF package returns supervision.detections objects. Using supervisions is built. Annotators from drawing will be the simplest path, but adds a dependency. Okay, that's what I was saying. But alternative extract raw arrays and draw with OpenCV recommended using supervision since it's already an RF dependency. Okay, so if we use RF we need to install supervision. I'm not sure. I don't think so. I think it works fine. So I don't want supervision. Use OpenCV. So if we can select, let's already do this. So we're given the instructions and then I can start the plan as I want it. So this will already make the integration of our model work. So integrate RF with threaded inference and OpenCV overlay. Everything is great so far. So here it's just telling again the steps updated with my new adjustments. We are okay with that, so we can go. Let's read further considerations. RF model variant. We have RF base, 29 million params, fast versus RF large, 128 million params, more accurate. Recommend exposing this as a setting or inferring from the checkpoint to RF base. There are 4 models or RF. Actually, there are more. Let me get into it. To that RoboFlow RF. We have a few models. So you see on GitHub. Let's show this bottom left. GitHub. So RF real-time detection and segmentation, real-time state-of-the-art detection and segmentation. Pip install RF. I'm checking the 4 models list. We have Nano, the smallest one with 13.5 million parameters. small 32 millions, medium 33, large 33, not a big difference. What is the difference here? Okay, the size of the image is slightly more, but they use different image sizes. And then we have extra large and 2 extra large. What I trained for this one, the large version. So we have nano, small, medium, large, extra large, and 2 extra large. I trained this one, the RT that's large. And so let's now start the implementation. Chat, is everything clear so far? Do you have any questions about this? I'm keeping this as minimal as possible now. In the first 5 lives, I was just doing without any specific plan, putting features, everything that was coming to my mind during the live, I was just doing that. I'm not doing that anymore because I saw how inefficient that is and how brings you completely out of focus. After 4th live, doing building InspektLine, I had quite a complex software that was started to be hard to maintain and to improve. And I was missing completely the target of this. So the target is that we want to detect objects, we want to inspect objects, and I spent so much time adding features, select camera settings, make annotation in the app, so grabbing the frames. In the app, I integrated like how to annotate, is this label okay, is this label not okay. That was such a huge waste of time because I completely missed the point of the software. And the problem with this is that if you miss the key of the software, then it will fail at some point. It makes things so complex. So what I did in the previous live, before the previous live, I removed pretty much almost everything, and I decided to keep this as basic as possible. So this needs to do a few things. You need to just install it, run it, select the model that you have for your objects, press start inspection, and then you're going to have the inspection in real time. That's it. Nothing fancy, advanced, no database at the moment, nothing, no specific dashboards that bring you any information. That can be something that will be added later based on request, but we have to stick with what is our goal and not to miss the target of what we're building. And this is what I've been experiencing lately with vibe coding. I've been working on different side projects in addition to this one. Projects that I put on the side for many years. So since I feel I'm very creative, and for many years I had in mind many projects, but at some point I say I will never build this project because it doesn't make any sense. It will take months of work and it just doesn't make sense. Since I discovered vibe coding, I started play around with some of them, and I started to put a few prompts and to see, okay, can I make something with this? Okay, I didn't really have the idea to build a project. It was just a play. So just a play me with the PyCharm and just a few prompts, and to see, can I do something? And after a few prompts, the Copilot was giving me full ready code, full ready programs. It felt like so close to what I wanted to build. And I felt, wow, like I can do this in 1 week. I already have most of it. And so at least in my experience, you start digging rabbit hole, and then you enter into something that you are close to there, but it never reaches what you want to reach. And it feels like, in my experience, playing a slot machine. I know that is a strong statement. Tell me, chat, if you have the same experience from vibe coding. Vibe coding is like playing a slot machine. You are just one prompt to reach that, just one more prompt, and the hour that you wanted to put in that project become days, the days that you wanted to put become weeks, with this rush to, okay, I'm close to this, okay, some more prompt and it's fixed, I will make it, tomorrow it's ready, and then you spend weeks into this. It's so frustrating. So that's been my experience. Build everything I have in mind, saying, okay, I will manage with web coding, I will manage everything. It's true that you can do things that you probably wouldn't do before, but at the same time, if you don't have a plan before jumping into vibe coding, you're going to get lost. There is always this feeling, again, slot machine, like addiction feeling, because you are always close to something. And not only because the outcome is so unpredictable, you cannot even plan and predict what you will do. Because you can, when you code by yourself, you can more or less estimate. Of course, it's not always easy, especially if it's a research project. You cannot know exactly how long it will take. But if you have to write a file for loading a detection model to display something, or if you have to display a dashboard, you can estimate, okay, it might take 1 day to finish this. Let's say it might take 10 hours. Of course, you might miss even by a lot, by 2-3 times how much it takes. That's not easy. I mean, I do this mistake all the time with research projects because you don't know. But with vibe coding, it's 10 times, 100 times this. The things that you think, oh, this might take 1 week, vibe coding will solve that with a couple of prompts. And then something that you think, okay, this will take 1 prompt because it's just one tiny mistake, and you might need to spend days because it doesn't, because the model, the vibe coding, the prompt doesn't understand what's the problem. And so your project become like, I don't know, like something very, very hard to manage, very hard to predict. And is it chat, do you have some similar experience with vibe coding? I will be curious to know this. Or if you're watching this video later, let me know in the comments if you have a similar vibe coding experience. How am I solving this experience personally? I'm coming with a very strict, specific, small plan that I want to reach. That's the thing that solves me this problem. Because in this way, I don't add extra features even if they're not strictly necessary. Because if you are planning to put a week into something, and that takes only a few prompts, then you have so much free time and say, okay, now since I'm already so far ahead, I can put this other feature that I would like to have, this other one, and then you miss the focus. Then you totally miss the focus. Now, I want this to be as automatic as possible. Allow always exact command in this session. Okay, so I want to give the Copilot the freedom, full freedom here. When you use GitHub, in PyCharm at least, the Copilot, okay, but why is it asking? Okay, let me give this the full, allow always exact command. When you use GitHub, in PyCharm, Copilot. If you don't allow, it will ask for can I edit this file, can I do this, can I do that, and so on. It puts so much friction, so I want to allow all of this, especially when you have a project where there is no private data whatsoever. So do this only if you are comfortable with the project that you have. If you have private data, always, of course, you need to know what you're doing. So I'm allowing the full freedom, even if this is not accepting it. I don't know why. Continue, allow okay, let's allow all commands in this section. Let's see if this is going to work in this moment. Let me put again the setup. So this is the setup that we will be using while the Copilot is working. I'm going to place a few objects on the conveyor belt. And later I will place this right here, by the way, in real time. I will place, so while the conveyor is moving, I will be placing this so that we will see the accurate counting of these objects that we are going to get. By the way, the other day yesterday I was recording a YouTube video, so if you're interested into this, watch my next YouTube videos next week, Wednesday next week, around 25th of March, where I show how to perform precise size measurement. Okay, not with this, with the camera, so I'm using the same setup. I show you how to do a precise size measurement. And I use this instrument to check, to make sure that the measurement was accurate, and we have a millimeter precision measurement. So this is something that I will also integrate again into this software at some point. Now I did this for a YouTube video, so next week just hit the bell, hit the notification bell, subscribe to the channel if you want to be notified about this. So not only I will be building live InspektLine. InspektLine, again, it's this one. Where is it? This one is InspektLine. Don't forget to put here the star on the GitHub project. You will be notified that when there will be updates about this project. But also on YouTube, put the subscribe, hit the bell, and you will be notified about new videos and new lives that I'm going to do. Okay, ops, maximum tools attempt reached. Opus, it's working quite a lot right now, so let's hope that our segmentation model will work right away. And I did this already, the app that I used to do the training, I created it with vibe coding using RFDet. So I already know that this will work, but let's see if it will work with the first attempt. Package requirement GXIPy. It's not satisfied. Why? GXIPy. Okay, it's not a package. It's a module that I have. GXIPy. It's the module that I'm using to load the industrial camera. This one right here. If you are just connecting right now, let me share you an overview about the setup. So this is real time. This is not a video, I mean not a frame. This is real time. We have conveyor belt, industrial camera, the hang imaging camera, non-distortion lens, which doesn't matter now, just a detail just to add it, connected to a frame grabber. This frame grabber is connected to my router, and then through the router I'm getting this in real time into the software, into the InspektLine software. Now what we will do, when the Copilot here, so I'm using Claude, Opus, when the processing here will finish, we should have the object segmentation integrated. It means that the conveyor, okay, let me slow it down a bit. The conveyor will be moving, like now you see it's moving very slow. When the objects are passing here below the camera will recognize these objects. These objects, we can do a few things. In this case, it will detect, will give the exact boundaries of the objects, and we will be able to count them. So in this video, we will do counting of these objects. And also we will do ROI. So we put a region of interest. That's, if we have time, what I want to add in today's software. Region of interest, if the object is crossing a specific area, we want to count that object. And I want to be able to put multiple region of interest, because there might be more complex setups. This is, of course, a very simple setup that I'm using here just for prototyping. But when I work with companies, the setups are more complex. There are multiple lanes. You want to detect different objects on multiple lanes from a single camera. So you need to have different regions where you detect these objects. So now, if everything is okay with this prompt, we should have this right now working. So let's now try that. Let's run our software main. So this one right here. If we click load model, so far it's not working, so I don't really know what's happening. Failed to open camera. Okay, let me close it. Failed to open camera. Sometimes it happens that when I close one session, it still didn't release the camera. So let's make sure that the camera is released. So let's run it again. Now it's working. So what you see now is this in real time. We have the camera right here in real time. We need to load our model. We can select, okay, we can select model type, RF depth, enable instant segmentation. I don't like how this is done, but I mean, I don't like the user experience, but it doesn't matter now. We need to get things working. Models. We can load this checkpoint base total. So this is the model that I trained to detect the steel rings. So if you're just coming now to the live, this is something that I explained at the beginning, how to train the model and so on. Let me put the glasses because of lighting. Let me clean it a bit first. The light, I have the softbox, some light in front of me just to have some good lighting for the video, but it's bothering a little bit, including the screen. So let's fix this. Okay, much, to some extent, better. It's not working. I was saying, if you are coming now to the live, I explained this at the beginning, how we created the model. So I have the model. Now, we need to load the model to identify in real time the steel rings. So how to do that? We integrated here RF depth, failed to load the model. Since we're using Copilot, since code is right in the code, I don't know what's the error. So the only thing I can do is to find here the code. Failed to load model, error is loading state of dict for all LW depth. Size mismatch, weight, copying parameters with shape. Okay, there is some mismatch. What I know that for the RF depth models, we have to specify what model you used. I want to be able to specify what model I used. So, because we have nano, small, medium, large, extra large, double extra large. Based on what model you use, you have to specify so that it loads the right part of the library. So do the following fixes on how to do this. So let me run again the software. I want to see what we have in the interface. So right now on model type, we can choose classifier RF-det, and then if we choose RF-det, we can say enable instance segmentation. Doesn't make sense this. I want now to choose RF-det detection. So I instead of choosing model right away, I want to choose task type, classification, detection, segmentation, and then when I choose the task, I want to choose the model I'm going to use, RF-det, seg, large, medium, and so on. So let's run it like this to give the exact. So we need to specify the exact model that we are loading. Right now it doesn't allow me to do that, and I think that's one of the causes of the error. I mean, I was using RF-det yesterday or 2 days ago, even yesterday, because I recorded a YouTube video for size measurements, and I use RF-det, and so I had to specify large model and so on. Chat, I see we are more people now connected. Let me know where are you writing from. Well, so far from Germany and from Ireland, we have 2 countries now that reply to the chat. Let's see, do we have any more countries watching now live these streams? I'm streaming from Sofia, by the way, Bulgaria, Europe, to give context if someone doesn't know. 3:27 p.m. my time. Update the RF-det detector to accept the full model variant. Okay, task types, we have Hugging Face classifier, detection. Okay, so far it's okay. RF-det detection model, segmentation, RF-det segmentation. I think that everything is correct to what I see here in the planning. I'm in the UK. Okay, hi, welcome Martin Parker from UK. Then you are 2 hours back from me, so it's 1:28 for you. Is chat everything clear so far? Is it some topic that, if you don't mind to reply, some topic that interested you because you are studying it, you are interested, or because you are working on some specific use case like this? Both way, I mean, both is good. If you are studying such topic, I'm trying to give as much value, as much information as possible while I build live. If you need something similar, then you will find this project on github.com/pysource.com/InspektLine. Now, there is not much documentation, there is not much that you can use yet, because we don't have a ready-to-use software yet, but soon there will be something that you could download, install, and run if you need to use a similar setup, whether you need it for your own use case, or whether you want it for a company where you're working. So if you work in a company, if you deal with visual inspection, then that's something that you might need to integrate, that you might want to integrate. So this app might be good for you. Replace the old 2-option classifier. Okay, now let's try this. So I'm going to close this that I have right now, and let me close also the chat. No. Okay, let's run this one. You do some great videos. As I've been a subscriber for a while now. Wow, thank you so much, Martin Parker. I'm great. I'm glad to hear such feedback. Unfortunately, I've been quite absent with videos lately. I've been, like, in the last 3 months, I didn't post a single video. I was quite busy building. This is a good announcement that I will make. I'm releasing soon, in addition to this, a software for annotation and training. So imagine something like RoboFlow, CVAT, and similar tools with one big difference. Everything will run locally. You can do the annotation locally. You can do the automatic annotation locally because I integrated the SAM models. It's going to be amazing. So I guarantee you, I'm using that software myself. I can't release it now because I have to debug it. I have to fix a few things. But soon I will also release this with the next videos. Not only, a new video is coming next week. So I'm also slowly back into making videos again. I'm vibe coding a bit less now. I'm being more cynic on things that need to be done. Now, this is running. Let's now try. So let's select task segmentation. Then the model rf.seg large. Let's load the model. So far the software is okay. Let's load this one. I'm just having lunch whilst watching you live. Not often I get to watch live. I'm looking to do an OpenCV project for home. Oh, cool. I hope you are enjoying your lunch, Martin. Yeah, imagine like that people are busy, and so that thank you for the time you are being here. Are you going to do vibe coding, Martin, or more normal coding? I mean, the video always share like normal coding. Now this live it's more vibe coding, so I'm using Copilot to be very fast and efficient. Okay, now the model is loaded. Let's now try the model. Start inspection. Inspection is running. Inference error backbone require input shape divisible by 24. Let's see. Okay, first of all, let's commit the changes that I have so far, even if it's not working fully. So add. What I added now are that detection and segmentation. There is some bug. So I'm putting a comment here. So we added this. Let me push this change on GitHub. And now let's click. Okay, now we have some errors. So the model is not loading properly. Backbone requires input shape. Model is not optimized for inference. Okay, I'm going to give everything that I have right here to the Copilot. I'm getting this error using rf that large, like this. And let's go like this. Resolution 500 is, okay. I think I got why we have this error. Somehow the sizing of the image is not correct. That's the problem with vibe coding. Often it's just hit and then you see what happens. It's yeah, you're just playing with a slot machine. Most of the time it works, Most of the time it works, and if you try enough, it will work at some point. I mean, in most of the cases, not always, but it's always good to have a knowledge. I would say it's essential to have a knowledge on what you're doing. Yeah, I prefer to do my own Python coding. I understand AI, but can be very useful, but I'm a hands-on learner. Oh, I totally agree, Martin. Totally agree. I've been like so only coding. Then I discovered vibe coding. I've been full into vibe coding, and now I'm slowly making a step back and just do a bit on both. Check. Now, of course, in the live, I'm more to get things done fast. I'm more into this. But I noticed there are so many cons also vibe coding. First one, you don't learn much. I'm discovering that I use vibe coding for a lot of stuff that it's out of my expertise. So not only I've been building computer vision, but I'm integrating dashboards, doing websites and so on, which is a bit more out of my expertise. I did some website, I put like control panel, admin, everything, but my experience and my learning, it's very, very superficial, and I don't learn much, at least if I do vibe coding this way. Like, I like to do it when in my free time, when I'm alone, to do coding, then check vibe coding, understand what is writing, why it is writing in that way. So it's, yeah, I will use bit of both, but with careful precautions. Macaxeira, the model is already trained. Yes, I already trained the model. Let me show for everyone that is joining now. So I use my own software to train the model. That's something that I will release soon. So if you are interested about model training locally, easily, stay tuned, and as soon as possible we'll release this software. This is what I have. So I will show you what model I train. Okay, now actually I'm running the wrong version, so let me pause a moment. Let me pause. Is this one? So this is the old version of the annotation tool. Okay, this one should be the new version. I'm not sure because I have so many versions of this annotation tool on different computer. Okay, yeah, I have this annotation tool. So I use this to train my own my model. So I have 493 images of steel rings. As you can see, they are all annotated. We have annotation for each steel ring. And then I train, so here I click train, and then I select the model training, instant segmentation, and I train the large model. So I have RF, that segmentation, large model train to detect and segment the steel rings that we have here. Now, while we try to fix this problem, while the copilot is trying to fix this problem, let's see how is it going. Now update on page, on task type change. Well, I did a lot of work here, but for what I understood, there was one specific problem. The object detection models, the image that you pass to the object detection model needs to have a specific size. For example, in YOLO, at least in the past, now I'm not sure with the new models, it needed to be multiple of 32. So didn't matter how big was your image. Normally it will be shrinked. Now it's shrinked also to a fraction of that. in the older models, like the YOLO version 3, it will be shrink to a 416 by 416. So even if you had a full HD image, it will be shrink to a square. So even the proportion will be totally distorted. A small square of 416 by 416. The new versions are resizing this to 640 by 640, keeping the proportions. So if the image is, let's say, wide, it's not a square, so the larger one will be 640 and the other one will be resized accordingly. With our RF depth, you have sizes that are shown here. So RF depth large, okay, you don't see it now because I'm hiding. RF depth large is 704 pixels. RF depth base 560, 576. You can change the size of the images, but they need to be a multiple. So RF depth is asking that this should be multiple of 24. I'm not sure if they are correct. So if we say 704 divided 24, 29, I'm not sure. 704 divided by 32. So what I know that it from the previous YOLO models, the image should have been always a multiple of 32. So sizes were used 416, 512, 832, 1024, and so on. This one, RF depth is using a bit different sizes, but I think that they should be always multiple of 32. Let's see. RF depth large require resolution 704 pixels, but the code was hard-coded to 560 pixels. Each model variant has its own native default resolution, forcing 560 across all variants because Backbone requires input shape to be divisible by 24. So is it 560 divided by 24? I really don't know what this says. 704 divided by 24 doesn't make sense. So I'm not sure we solved the error here, because for me it doesn't make sense. It's saying that it should be multiple of 24, but it's not. So let's see. Okay, now it's not loading the, okay, I have, why is it not loading the camera? Failed to load the camera. Okay, let me close this. The camera is probably already taken by the previous process. Let's run it again. So when we're, okay, now we can see the camera, and this is the real-time camera from the conveyor belt that we see right here. So let's try this. Segmentation. We select segmentation model. RF depth large, 504 pixels. Okay, in this case will make sense. If we say 504 divided 24, 20, okay, now 504 is divided by 24. Then it makes sense if that was the case. Load the model. Let's now select the model. I have here the model that I trained. So we open and we select this model. And let's see, loading pre-train weights. Okay, the model is loaded. Let's now start inspection. Nice. Okay, nice. Here we have the inspection. I'm so happy about this. Okay, we got the result. It's lagging. It's lagging because we're using the CPU. I hope that the streaming is not lagging right now. Let me see, performance. No, it's actually using the graphic card, so it's also using the CUDA graphic card. That's great. So let me check this one. Model is not optimized for inference. Latency be higher than expected. You can optimize the model for inference by calling model optimized for inference. Okay, that's something that I want to integrate. So here now the detection is working in real time. So pretty happy with the result. And now will be the fun part. So let's do some adjustments, and now this can work in real time. So we go, and I want to commit now this change. So right here, add rf that fixed bug, loading the model. So I'm committing this change because now everything is working. Now let me stop this and let's improve a bit the performance of the model. Okay, the graphic card is not used anymore as before, so it means that yeah, we were using it for that specific purpose. So let's now do this. I want to fix this. We're exploring the addition, okay, Matthews Jacob. We're exploring the addition of a no-code drag-and-drop editor for image preprocessing, inspired by MVTech Merlik. The goal is to let user design pipeline that moves seamlessly from preprocessing to annotation, training, and inference, all within the same environment. Okay, that's interesting, Matthew. I saw some companies, could be that one VISO.ai, something like that. I don't know if RoboFlow does that. So you want to do like some sort of no-code platform for AI vision, for processing, I imagine like put the model and so on. I don't know personally by this MVTech Merlik. So let's now run this. Okay, so let's load the model again, segmentation. Large. And now let's select the model. So we go on models, checkpoint best total. Now the model should be optimized also for inference, convert into a tensor. Okay, the optimization, the last command didn't work as expected probably. Let's run this. Let's start inspection. I'm not sure it's optimized. I mean, it is working, but it's quite slow. I think we're getting some error. Wow, it's extremely slow. It's extremely slow, despite we're using the graphic card. That's one of the problems now with vibe coding. So we're detecting the objects from the conveyor belt, which is a great result. But it's extremely, extremely slow. It's lagging a lot. Iterative over a tensor might cause the trace to be incorrect. Passing a tensor different shape won't change the number. So in this case, what I will do, if I wanted to do things properly, I would have to run the RFDet on a single page without the user interface. So I'm going to do that. So we need to do a bit of debugging with this. Unfortunately, that's the way we have to go. I want to create a test. RFDet is better than YOLO model. In my experience, so I'm new to RFDet. It's to some extent, yes. Especially segmentation, I notice very big improvements in how the segmentation, the polygon is accurate. I noticed at least in the YOLO 11 model, the segmentation was quite, I would say, pixelated. So if you will zoom, there will be like a lot of, it wasn't very round and very smooth, while RFDet looks much better. Another thing that I noticed with RFDet, okay, there are a few things why I will say RFDet is better, but take my words like just an opinion without any big testing so far of that. Another thing is on the training, I noticed it takes less memory, so we can train with smaller card if you have a smaller card, while YOLO, it fills the memory quite easy, especially if you increase the image size from 640 to 1280, for example. Even my card, I have 24 gigabytes of VRAM, sometimes doesn't fit the model, which is, I mean, like, of course, which you can put lower batch size and so on, but that's my experience. RFDet, also there is the improvement on I missed now. I got a bit lost. There was something else. The licensing also. The licensing, RFDet and YOLO, it's quite different. YOLO is on IAGPL licenses, while RFDet is Apache 2.0. So that's a choice that you can do when integrating the model in your company. The licenses, what are the freedom that you can use the specific model. RFDet allows much more freedom than YOLO does. Another thing that I was saying is that with RFDet, probably you need a bigger data set for the training. I'm off back to work now, but we'll watch back what I miss. Also Martin, I would be happy also if it happens to see on the next lives. I'm still deciding on which I will find maybe different times where to stream. Now I'm trying different streaming on different times, sometimes in the morning, sometimes in the afternoon. I will find maybe a more stable timing for streaming, and I will see what can fit with different countries. Hi Zebulun, nice to see you. I remember you from the first lives from Paris. Welcome back to the live. Nice to see you here. How are you doing, Zebulun? I want to create a test for the RFDet model running on OpenCV, running with OpenCV. So I can test not the model. So now I want to create a test not for the model of the RFDet module, of the segmentation module running with OpenCV, using as test this models, and then I provide the model. I have checkpoint best total.pth, which is RFDet large instance segmentation model. I want to test, I want a test so I can make sure it works properly with write speed. Okay, here I'm just giving some suggestion to the Copilot. Now my computer is stuck. I hope that the live is still going. What is going on? My machine is freezing. Okay, not anymore. The problem is that I have this RF this file running and it's taking a lot of space. I think I fill the RAM memory. Let me see from the phone if I'm still live. Chat, if you see that I'm live, let me know. Fortunately, everything looks very stuck. Can't do anything. Yeah, the live is going. I see that the live is going, but I cannot do anything on my machine, unfortunately. Everything is stuck. My suspect is that the RAM got full. I will wait a bit. Let's see if this gets unstuck. I think it has been filling the memory. I think something has been filling the memory and then it got to this point. I cannot do anything. Okay, task manager. Okay, as I was expecting, you see my RAM memory is full. I have to be able to stop the process here and I should get the memory back. It's completely freezing. Okay, in the meantime, I see some updates from the chat. Amrabu Gazala, welcome to the live. You are unfortunately not in an easy moment here. My computer is completely stuck. That's the nice of being live. I cannot do anything. So what is happening right here? The thing that's happening is that the software that I created has been filling the RAM memory somehow. I don't know how, probably putting the frame in some cache. And so my RAM is fully filled and there is no way I can use any app. Now I'm trying to, okay, I manage. Finally. Chat, I just got back. I managed to stop it somehow. I managed to stop it. So I got back now. You see the memory was full, was 32 gigabytes of RAM, was completely full for no reason, because I don't need that much memory. So there is some bug for sure with the program, but at least now it's working. So I see a few new people connected. Hi chat, let me know where are you writing from. We have few people from Paris, we have people from Germany, UK. And for the newcomers, let me show you what we're doing. We're building a visual inspection software completely from scratch. This is the 6th episode. I have a setup here. This is a conveyor belt, industrial camera. The camera is connected to a frame grabber, which is connected to my router, and then from there I grab the frame, which they will go into the software. What's the goal of today? Today's goal, we have two goals. First, to integrate the object detection model and count this object right here. So I have steel rings. And this is an example. I'm showing this because it's an example, but you can do this with any object actually. We're going to count this in real time and select region of interest where we can count them Why? Because companies might need, in my experience, they can have one camera, multiple conveyor belts. So you want regions where you can select what you want to count. Hi from Germany. Okay, we have more people from Germany. Also, someone at the beginning of the live was from Germany. Great to see that you are coming to my live from Germany. So I show you the setup. This is an open source project that you can find at GitHub, Pysource.com, InspektLine. The link is pinned into the chat if you want to click. Put a star on it if you want to follow the updates of this project. Now, everything is working regarding the detection. So I have already a model to detect the steel rings. We are fighting here with some bugs, which is normal with vibe coding. When you move so fast, the vibe coding doesn't know exactly if something is wrong. So we move very fast, and very fast we also have bugs to solve. One of that was that it was filling the memory completely until I wasn't able to use my machine any longer. So what I'm doing now I'm doing a test file. So you see, let me hide for a moment the camera. So you see tests. Here I want to test the segmentation. I want to test the segmentation separate from the program, because on the program everything is running very slow, and so I'm not sure why this is happening. So we need to make a step back and break the problem down into smaller steps. So test segmentation. I'm using vibe coding just for reference for everyone that's new to the live, Claude Opus 4.6. And now let's go and try the file test segmentation. So if we run this one, Python test in test segmentation, test passed, but I would like to see this in real time. Max call inference time. Okay, the test is just calculating the time. So let's see what the test provides as a result. And tests are something that it's good always to integrate. Good to integrate to make the software more stable and for the maintenance over the long run. 25% pass, 29%. 19.8 frames per second, which is good. Okay, according to the test, okay, I want also a file. I want also a file that shows OpenCV in real time as a test, so not the actual Python test. Okay, here it shows the output of the test. One image, defect. Okay, defect is not true, there is no defect. It's the actual detection of the steel ring, that's not a defect. Demo segmentation in real time. Okay, that's what I want, but I want to run it. I don't want to use argparse, instead load always the video, the model, the camera, and model from the folder models. Checkpoint best total.pth, which is rf large instance segmentation. The reason why I want this file is to make sure that the speed of the detection is okay, because when I run this on the main software, it lags completely, it's very slow, and I want to make sure that the problem of the detection, the speed, or if it's problem of the integration with the main user software. Okay, no real error. Okay, let's run this. Demo segmentation in real time. Checkpoint. So now it's loading the model, loading the weights. There is some error or some warnings, I will say. Opening camera index. I don't want camera index, but I want the industrial camera. So what is this using? I want to use the camera to use industrial GXIPY. Okay, I'm getting a bit lost with the agent. I hope it will be a bit faster right here. Also, we will be wrapping this up soon, so I will say at least I reached one goal for today. It's not exactly what I wanted to reach. That's one of the things that I was describing at the beginning. Sometimes with vibe coding, it's a slot machine. You can really not know how long it will take to build something. Something that can take a week, that you think it will take a week, might take a few prompts. Something that you think it will take a few prompts might take a week. And the debugging sometimes can be quite painful. I've had this experience lately building my own other side projects where I really wasted so much time on small errors. Okay, that's now the frame in real time, which feels very slow. Could be worse, let's say. But let me see a moment how we're using the memory, not to have the same problem as before. Well, CPU usage is quite high. Memory usage, it's stable so far. So this is the segmentation model now that we have for the steel rings from the conveyor belt. So if we run this, I know it will be a bit slow, but let's see. Let's see. There is, of course, some delay. Oh, it's working. So you see the objects are crossing, they are detected quite well. What we have from the main camera, what we detect from the industrial camera right here. Everything is happening in real time. You see. So let me run this again from the main software. So the speed is not terrible, not great, but it's not so bad. I'm getting around 20 frames per second. So let's try and see if the main software has the same speed. So if we run the main software, Okay, here we have the main software. Of course, I have to load the model, so we load segmentation model. So now there is no detection. The speed is okay. So you see it's quite fast. There is some delay because it's connected through Ethernet, that's okay, but the speed is fine. If we load the model, so let's load model. From models, checkpoint best total. Let's wait a bit that the model loads. Okay, model loaded, ready to inspect. So let's now run the inspection. Okay, the inspection is working. I'm keeping an eye that everything is working correctly. So let's see the speed of the software in action. If it's much slower, wow, it's extremely slow. It's no. It's extremely slow. So there is something with the multi-threading, I will say. I can't really know. So let me block this. Anyway, let's fix add test, add rf that test. So the model is working, the detection is working, the speed is not good. So so let me try to fix this with the copilot. So let's give some new prompt. The speed is very, so model detection works well on tests, but when I use RF that in real time with the main.py software, what happens in that case, it's extremely laggy, slow. I want to fix this. It should work with multi-threading. So somehow there is some interference between the user interface, the main software, and the backend. So before integrating any other things, I need to fix this. So there is no way to that we can work the software like this right now, or that we can add other features. Let me know, chat, hey, is everything clear so far? If you have any questions, feel free to ask on the way. I'm here to chat and to have something interactive. So I want this live to be building live, but also like if there is some interaction, I'm happy always to discuss, chat, and reply. Especially on these dead times where there is a lot to debug. When we build new features, it's usually we can go very fast, but when we have to debug, then we can have some problem. Main thread is blocking the waiting for inference to complete. Okay, there is something happening here. The main thread is somehow blocking. Faza, what are your plans for selling this? I am wondering a lot how to approach customers for this. True, that's that's a big part of making a software work. One is the creating the software, which for us technical people, like for me, it's the easiest part. The distribution, maintenance, and all the rest, then that's the tough part, at least because it's out of my our area of expertise. It depends. So it depends on the position you are in. So I am in a position where, let's say, I publish video. I have at least some people that I know I can be already interested into this. So the idea is to show some proof of how things work into an open source project. So distribute this free open source project, and then find some deal with specific companies where I give a paid version which will be more optimized. It will be more optimized with all the features that can be necessary in the environment. So one thing could be give support. That's one. Optimization. So while this is a software not optimized for the companies, they could be optimized. It could work, for example, they wanted to work with one small board device, or maybe they need support to make this run in the cloud, like Amazon AWS. Normally, also why I built this is because I have already some clients that need such software, and what I'm doing now, I'm coding per client request. So that's what I do. What I want to do is I want to scale this a bit more. So I will have a package product, which is InspektLine, the, let's say, enterprise plan. I'm thinking where it will be priced to buy the source code to use on the company, and then to offer a monthly maintenance package or yearly maintenance package. That's my idea of distribution at the moment. Not sure it's the best, not sure. That's, I think, it's what fits me in the position that I am. If I wasn't in this position, I would be if I wasn't in this position, I would be doing still something like this and recording many small videos. So for example, I will put a lot of videos on LinkedIn, a lot of demos. I will take a lot of products on this conveyor belt, put a lot of demos, and I will share this on LinkedIn. There could be something where to find potential customers. If you are more extrovert, if you want to, that would be the best way to find the company directly, contact them, go on your company, on your local area if you have the chance. That would be like the top best thing that you could do if you want to make things work quickly and fast, and if you want to be more in touch with the real environment. So that depends a lot on there are so many ways to distribute this that I can think of. I will go, for me, with this way. I will see if it works, I will keep doing this. If it will not, I will change strategy. Also, are there any job vision engineer role in Europe? Because I can't find too much of them in Ireland. I'm not well aware of the market. I never look for a specific job. I know that it's not an easy time for engineering job. I saw like some recently on my LinkedIn some open position engineer in Sofia, but which is very rare. Like I got this suggestion, but I think it's the first time that I see such opening position in Sofia. And around Europe, to be honest, yeah, I don't know. There must be. It's a market that still has a lot of potential to grow. The problem is that so many companies still, they are a bit outdated into this. So to have for companies to look for such position, there must be already some manager, someone that is trying to implement such solutions in the company. So yeah, I don't know. So Fazal, to reply, yeah, I don't know. I don't have experience with the market personally. The job market, at least, because it's out again of my area of expertise, since I always work like a freelancer. Okay, let's see. Changes made it across 4 files. Detector, RF data detector, added torch inference mode, service inspection service, refactor inference thread, event-based wake up replace time sleep interval, polling with threading event, pre-annotated frames, detection overlays boxes are now drawn in the inference thread and stored as latest annotated frame. Let's see how this works. So software is running, which is good. Let's select segmentation. Let's select the RF that large. Let's load the model. Let's go with models, checkpoint best total, which is the steel ring RF that large model. Now the model is loading. It's showing us some warning, which is okay, as long as we don't get an error. Let's see the speed. And the speed is working great. Chat, let's have a look at this. So we are almost ready for the new integration, because now it seems that everything is working as I wanted this to work. So you see in real time, here the inspection. Yeah, we can call this inspection. We have the steel rings crossing. Steel rings are detected like this. It's working. Chat, have a look at this. Everything is working pretty well. So very happy of the results that I got so far. Let's pause the conveyor right now. And I want to focus at least on achieving one target for today. So of course, count of objects. Bravo, thank you. Counting of objects on a conveyor belt. Let's achieve at least this. I want to draw an ROI and count objects on a specific ROI. I mean, which will be the 2 targets. So today so far I was not happy with the result, because almost 2 hours in and I wasn't reaching what I wanted. So RF that fixed. So we fixed the RF that bug. So let me add this, fix RF that bugs. So it's working, and now let's hopefully run the last command, last prompt. I want to integrate RF that. No, I want to be able to draw an ROI and count objects crossing that ROI. So to segmentation, add object tracking. So it's quite a lot that we're asking now to the agent, but let's try. Let's give it a go. It's a lot to ask in one time. So we need object tracking. Why do we need object tracking? We need object tracking. Let me explain why. So this is now the real-time segmentation. If I move these objects from this position to this position, we know it's the same object. But the AI, the software, doesn't know it's the same object, because what we see in images, like our brain makes the connection, we see the movement, but Here the software doesn't make the connection because it works frame by frame, so image after image, and every image is new. So we need a tracking algorithm which tracks the object over time. So add a tracker by track via supervision on top of this. Okay, let's go with supervision. And later I might remove supervision because it has a lot of stuff, not only the tracker. I want to keep this as minimal as possible. For now, let's use supervision because it's the fastest way. Integrate the tracker into inference service, extend annotate with draw ROI line, helper, add ROI draw interaction to video label, mouse press event, ROI controls. So far, everything is good. Tracker choice by track is lightweight CPU. If more robust, okay, ROI shape, line versus polygon, line 2 points. Polygon, I want ROI, I want polygon. Persistence of the ROI line, 3, yes, save. No, now no saving at the moment. It would be nice to save the settings each time we run, but now we want to keep this as minimal as possible. We want to get results in real time. Let's make this run. All the other things will be adjusted on later stage. So that's the mistake that I want to avoid making right now. I want to achieve these two goals: select ROIs and count per ROI. Count objects on a conveyor belt. Okay, this, let's say it's one target. I put it in 2. I want to count objects per single region of interest. I don't want to add too many features at the moment. So I don't want to save the region of interest. I don't want to save the location, the model that I'm loading each time. No, I will do that on a later stage. First, I want the software to be as minimal as possible and to be running with the lowest amount of features possible. Why? Because the least we have, the less we have, the better it will, the easier it will be to maintain, the easier it will be to develop, to add things that are strictly necessary. If I add so much from now, then later on, software is going to be very heavy, hard to maintain, and it missed the target. Our target is to keep things simple and to keep things that work. That's what company want. When you provide such software, a company wants to make sure that they integrate the inspection because they cannot do manual inspection, so they're losing money because of the reason. There is lost reputation and all the things that come from not having a proper inspection of the products. They don't care of having the beautiful button that or like the pretty interface there. Things need to work. Doesn't matter how, things need to work, doesn't matter how ugly they are. Of course, when things can be improved later, when there is some feedback. But first thing first, let's make this work, and just later we want to bring this to add new things. Okay, now I wanted to just keep things simple here, but it's taking our supervision requirements, create detector. It's getting quite lost with the thinking here, the planning. These are golden words, speaks a lot of experience. Thank you, Faza. Yes, it's I learn by trial and error usually, and I've been hitting my head so many times on this, and I decided like it's not the case to waste time on unnecessary things. While it's there the temptation to just add something more all the time, especially with vibe coding, which requires only a prompt. Like, it's like, oh, why not to add? It doesn't take much. Like, why not to do it? But also in my last experience, the last 2 months where I've been vibe coding like like crazy. Like you have no idea how many hours I spent with vibe coding. I finished my credits with GitHub Copilot, and so I don't know how many requests I did, but maybe like 2,000 requests or something like that. So I had my $40 Copilot Pro Plus. I finished my credits after like 20 days because I was so into vibe coding, and then I got a bit burnout of that, so I'm slowing down a lot now. Well, here it's thinking too much. Let's just I don't know why it's thinking this much with even the planning. I don't know why it's usually the planning here. It's very fast. I'm looking for a helper method that finds labeled text. Well, but there might be a reason why it's thinking so much. Huh. It would be so cool if with this prompt the counting will work right away. It would be so amazing. I'm also realizing the draw array. Okay, it feels like the Copilot has got into some rabbit hole. Yeah, true. Sometimes I think to put in, don't think too much in every prompt. Yeah, yeah. I should do that. I should. I'll put a time limit, like just stop like after like 20 seconds. Yeah, just mumbling something about the button. Let's start implementation. I don't even, okay. I don't, okay, it doesn't even start probably until. So I have to stop this edge case and they click right after resize the next frame, which could cause the polygon to be slightly off. Wow, there is so much going into this. It would be great if we can interrupt between. Oh, we can. I think we can. If I click here, I can interrupt. But yeah, it will be probably stopping everything. Writing implementation code. Number. No, it's just. I think that it's just getting out of stop. Doesn't make any sense. Can I start implementation now? Let's see, start implementation. I'll implement this step by step. Let me start by reading all the files. Okay, good. Now let me implement everything. I worked through 6 file requirements, detector. Okay, this will be my last prompt for today. So whether this goes well or not, I'm 2 hours in. So it will be my last prompt. So let's hope that everything, I mean, hope like, if not like next live, I will start from this bug. At least I got close to the goal today. I integrated the object detection model. Okay, here we have object tracker, object detection, object segmentation. I was a bit ambitious probably to put in the count in a single day. I expected it would be much faster to integrate the detection right away. Also because now I'm pretty tired after 2 hours of live. It's pretty exhausting at this point, so I will finish this. I hope that you chat enjoyed the live. If you are interested to learn computer vision, if you are building computer vision software, if you need help, support, always I have a community. It's called AI Vision Academy. The link is in the description of this live, in the description of every video. There you can find courses. You have community access where you can describe your project, and I'm always there to help and support the members with any project you are working with. And also we have monthly Q&A calls where we gather a few people, anyone who wants to join, and then we can chat, we can discuss about our updates and project, again, if you need project support. Let's integrate. Okay, let's see how is this going. Thanks a lot for going and keeping things running. Okay, thank you, Faza. Yeah, and finally I'm back to the live after a big break. I've been doing too many lives all at the same time, and it got me a bit burned out, to be honest. When I started with lives, I was streaming too many times per week, and I couldn't manage with the rest of the projects, so I got a bit burned out, and then I took a break. Now I want to be more constant, to have live maybe at least once a week. Now I will be off next week, and I will be back for the next live in April, but next week again I'm releasing a video. So for anyone that it's interesting to know more about this topic, there will be a video releasing next week, 25th of March, about detecting size of objects. And the video is more concise, so the video, when I make video, are 20-25 minutes, very concise on a topic. Now of course the live will be, it's always more a chat. You might learn less from the live, so it's a different experience. So if you want more concise experience, then the video is for you. Positive things of the live is that somehow when I speak, it makes me drink a lot. So it's good to keep the body hydrated. If anyone like me forgets about drinking, you can follow me. Every time I take the glass, you can drink with me. Now it's the moment of the truth. So the copilot here is finished. So if everything is working correctly, we should see this. Load the detection segmentation model that we already had. Start inspection, click draw ROI in the inside panel. Left click on the video to place a polygon vertices, right click or double click to close the polygon. Objects are tracked with persistent IDs, the overlay shown. So we have the tracking, so we know what objects, the specific ID of the object. At least that's the hope. Let's see how it works and if it works. So let's go here with main. So we have draw ROI, very interesting. So let's try that. Draw ROI. So I want to count the objects when they cross this area. Can I close the polygon like this? I'm not sure it can close the polygon. Okay, there is an error, failed. Right click or double click to close the polygon. Okay, somehow the polygon 1, 2, 3, 4. I'm not sure if the polygon is working. So let's try. Let's give it a go. So the model is large model. We load the model that I have in models right here. Checkpoint base total. Now, In a few seconds, the model is loading. Now it's loading into the memory of the graphic card. And now, maybe let's try to draw the arrow eye now. So 1, 2, 3. I don't know, it doesn't look like it's working. Okay, now the array is displaying. So in zone we have one element. So chat, this is the moment where we are counting the objects. It's not visible in zone, so let me do the last prompt. So increase the size of okay, let me first try it. Okay, no prompt, let's just try it because it's already late here. So is this working? Not great. Also, probably the detection now is not working well because the light is not great, I believe. I'm not sure. Something seems off. Also, no, there is some bugs for sure. Something is not working as it should be. Okay, then let me stop this. Not as I was expecting. So thank you everyone that came here. Thank you for watching. Thank you for participating in the chat. We were close to the goal. Something is there, but this needs still more fine-tuning. There will be a video on Wednesday, so if you want to see the next video, subscribe to the channel, hit the bell. On Wednesday I'm releasing a new video where I get into the topic of size recognition in real time from a conveyor belt. There will be more live coding there. Ambra, thank you to you for being here. Thank you, Faz. Now I'm just mentioning you the last two in the chat. And I will make a post when I'm going in the next live. Next live now will be in April because I will be off next week, and then I will be more constant, like to have weekly lives. Thank you everyone for watching. See you in the next live.